0315 hours. Bear Island, southern sector, minus 35 degrees Celsius. The last transmission from Unit 30 Commando, 9 Group Special Reconnaissance Squadron, the Royal Marines' most capable long-range surveillance element, is 2 words. Broken shield. Then nothing. The unit had been forward deployed aboard Lynx over-snow reconnaissance vehicles, establishing a passive electronic observation post designed to monitor Russian submarine transit corridors through the gap between Bear Island and the Norwegian mainland. The post was the forward nerve ending of NATO's Arctic Sentry operation, the most ambitious northern surveillance expansion the alliance had attempted in 30 years. Launching today with P-8A Poseidon maritime patrol aircraft and a new distributed seabed sensor network stretching from Svalbard to Tromsø, it never got the chance to go fully online. The Royal Marines' early warning receivers registered wideband jamming across the entire operational spectrum in the seconds before the unit went dark. A signal strength and frequency profile consistent with the Krasika 4 system, a Russian ground-based electronic warfare complex capable of saturating early warning systems at ranges exceeding 300 kilometers. The jamming came first. Then, something else followed it. A localized high-power microwave pulse, transmitted from a vertical launch system aboard what triangulation data later identified as an Ivan Papanin-class nuclear-powered icebreaker, positioned 50 kilometers east of Bear Island. The HPM pulse is not a jamming signal. It is a weapon. It induces voltage spikes in unshielded electronic circuitry that destroy components without producing heat or visible damage. The Lynx vehicle's navigation systems, communications equipment, and optical sensor arrays were incinerated from the inside in milliseconds. The broken shield signal was transmitted in the approximately 0.8 seconds between the arrival of the jamming and the arrival of the microwave pulse. Someone in that unit understood what was coming fast enough to get the alert out before it arrived. That was the last anyone heard from them. 40 meters below the seafloor in the same sector, NATO's Distributed Acoustic Sensing Array, fiber optic cables threaded along the seabed that function as a continuous passive acoustic sensor network capable of detecting submarine propulsion signatures across hundreds of kilometers, began returning error codes to the monitoring station in Brussels. Engineers confirmed it was not a hardware fault. Microseismic data from Norwegian geological sensors showed a stress fracture event at coordinates 76 degrees 30 minutes north, 19 degrees 45 minutes east, exactly the midpoint of the cable connecting Bear Island to the mainland early warning infrastructure. The DAS network was severed. The forward observation post was gone. NATO's Arctic Sentry operation had been blinded in its first hours of existence. But the detail that produced the most concern inside the Pentagon that morning was not the severed cable or the silenced Marines. It was the final acoustic signature the DAS array recorded before it went offline. Hydroacoustic analysts at the NATO Joint Intelligence Technical Center processed the data for 3 hours before confirming what they were looking at. The signal did not match the propulsion profile of a Yasin-M attack submarine or any Boré-class ballistic missile boat. It was operating below 70 decibels across its entire frequency range, an acoustic output level that blends into the ambient noise floor of Arctic Ocean current movement. Traditional passive sonar systems discriminate submarine contacts by detecting propulsion noise above the environmental baseline. Something that operates at or below that baseline does not appear as a contact. It appears as ocean. What had severed the fiber optic cable was not a submarine in any conventional sense. It was Project 10,831, designated by NATO as the Losharik, an AS-12 nuclear-powered, deep submersible designed to operate at depths exceeding 600 meters, crewed by naval officers rather than enlisted ratings, built for a single purpose: to access and manipulate objects on the seafloor with robotic precision. The hydroacoustic experts confirmed it was not operating alone. The DAS data showed acoustic signatures consistent with a swarm of support vehicles working in coordinated formation, an orchestrated seabed operation that had been running silently for hours before the first system error appeared in Brussels. By 0530, TASS issued a 4-sentence statement describing Northern Fleet activities as routine operations in international waters. Satellite imagery and open-source vessel tracking data painted a different picture. The Yuri Ivanov-class intelligence collection ship, Project 18,280, which had departed the Kola Peninsula 48 hours earlier under emissions silence, was positioned as the command node for the entire operation. It had not been sailing to conduct oceanographic research. The strategic logic behind the timing was not difficult to reconstruct. Moscow had chosen the night before NATO's Arctic Sentry activation to execute a preemptive blinding operation. The P-8A aircraft that were supposed to begin patrol operations today would now do so without the seabed sensor network those flights were designed to supplement. The Royal Marine Forward Observation element that was supposed to provide ground truth intelligence from Bear Island was gone. The fiber optic data highway that connected the entire northern surveillance architecture was cut at its most critical junction. NATO's most ambitious Arctic monitoring expansion had been rendered largely inoperable before it processed its first operational sensor report. There were two additional calculations embedded in the timing. The Northern Sea Route, the Arctic shipping corridor that Russia projects will carry 40 million tons of cargo annually by 2026, including liquefied natural gas from the Yamal and Stockman fields, requires freedom from Western surveillance to function as Moscow intends it to function. Ula-class nuclear submarines providing covert escort to commercial convoys through what Russia designates as internal waters cannot perform that function if NATO's DAS network and P-8 patrol aircraft have continuous acoustic coverage of the route. Eliminating that coverage was not incidental to the cable-cutting operation, it was the objective. The third calculation was specifically targeted at Britain. London had announced an expansion of the Camp Viking garrison to 2,000 Royal Marines, publicly framing it as a steel curtain across Norway's northern approaches. The Kremlin had just demonstrated that a steel curtain without communications, without GPS positioning data, without drone reconnaissance, and without seabed sensor connectivity is not a curtain. It is a collection of isolated personnel in an Arctic environment who cannot coordinate effectively and cannot see past the ridgeline in front of them. The announcement that Camp Viking represented a meaningful deterrent capability had aged poorly in approximately 6 hours. At 0600, Russia confirmed that the electronic pressure was not finished. The Murmansk BN system, a strategic-level high-frequency jamming complex, activated from the Ivan Papanin-class platforms at full power, projecting an interference dome across an area of 5,000 square kilometers. The effects at Camp Viking headquarters were immediate. GPS position data for deployed units degraded from meter-level accuracy to positional errors exceeding 15 kilometers. Watchkeeper reconnaissance drones lost navigation reference immediately after takeoff and crashed into the terrain before their operators could establish manual control. Lynx vehicles already deployed inland found their digital mapping systems offline, leaving crews navigating by paper chart in a blizzard with no position confirmation. The Marines were not in danger of being attacked. They were in danger of being irrelevant. Isolated by electronic means in terrain, they could no longer navigate with precision, unable to coordinate fires, unable to call for support on frequencies that were saturated with interference. The Royal Navy's response came from a domain Russia considered under its control. The RFA Proteus, a multi-role ocean surveillance vessel commissioned in 2025, equipped with deep-water intervention systems and an autonomous underwater vehicle deployment capability, entered the operational area under electronic emissions silence and deployed a swarm of Cetus Mark 39 unmanned underwater vehicles. These are not passive listening platforms. They are active intervention systems designed to operate at depths of 1,000 meters with manipulator arms, cameras, and sonar arrays, coordinated autonomously as a networked swarm. The mission was to locate the Losharik and its support vehicles and document the cable interference in enough detail to satisfy the legal threshold for response authorization. The Proteus commander made the decision to run active sonar, a deliberate choice to sacrifice acoustic stealth in exchange for rapid seabed mapping resolution. The Cetus swarm activated simultaneous flank sonar sweeps across the target area. The sound pulses propagated through the water column and returned detailed imagery of the seabed. Thermal sensors detected heat signatures inconsistent with the surrounding geology at 76 degrees 30 minutes north. The acoustic returns resolved into identifiable shapes: 3 AS-12 class submersibles and a surrounding constellation of autonomous support vehicles. Their robotic systems actively engaged with the cable conduit. The coordinates were relayed to a Norwegian Air Force P-8A Poseidon that had been holding in an orbit overhead. Stingray lightweight torpedoes were loaded and targeting solutions were computed. The finger on the launch authorization did not complete the command. Under Article 95 of UNCLOS, the Russian vessels, registered as scientific research platforms, were operating within the exclusive economic zone under protections that the legal architecture of international maritime law had not been updated to account for the specific scenario of a research vessel registration being used to conduct hostile seabed infrastructure operations. Firing on them without a formal declaration that their activities constituted an act of war would hand Moscow a legal argument and a propaganda advantage simultaneously. The NATO commander paused. The pause was exactly as long as Russia needed it to be. The Cetus swarm's active sonar had done something beyond mapping the seabed. The acoustic pulses had crossed the detection threshold of the Losharik's automatic defensive systems. The Russian vehicles registered active sonar contact and responded according to their program parameters. Shkval-type supercavitating torpedoes launched from the submersibles on autonomous targeting solutions. Their assigned targets were not the RFA Proteus. They were the Cetus drones and the sonobuoy field the P-8 had deployed. The sensors themselves, rather than the platforms deploying them. The explosions propagated through the water column and produced acoustic shock waves of sufficient intensity to saturate the Proteus's hydrophone arrays. The ship's underwater sensor picture went white with noise. Effective blindness in the acoustic domain, 3 hours, minimum. On the surface, a formation of Russian-flagged fishing vessels materialized across the Norwegian escort formation's track. Signals Intelligence later confirmed these were Vishnya-class intelligence collection ships in commercial disguise. They activated distress beacon transmissions on international maritime frequencies, which under the obligations of SOLAS created a legal compulsion for the Norwegian warships to reduce speed and alter course to investigate. The escort formation's ability to maneuver freely was constrained by a treaty designed to save lives at sea being operationalized as a tactical tool. The final layer came from above. The Cosmos 2553 satellite, operating in low Earth orbit, fired low-power laser dazzler pulses at Western optical reconnaissance satellites and commercial imagery platforms crossing the operational area. The pulses were below the threshold that would produce permanent damage, which would have constituted a clear act of war, but sufficient to saturate the sensors of imaging systems and produce unusable output for the duration of each pass. NATO's satellite coverage of the operational area went intermittent. The Starlink terminals that Camp Viking's communications relied on for encrypted data transfer dropped connectivity. Russia had achieved information dominance across all 4 operational domains: seabed, surface, air, and space, without firing a single weapon at a NATO uniform. In Brussels and London, the tactical situation map showed isolated Marines in the snow, a blinded sensor network, a degraded escort formation, and no real-time satellite imagery to work from. The Arctic Sentry operation that had been announced with considerable confidence 24 hours earlier was, in operational terms, not functioning. At a depth of 400 meters beneath the permanent polar ice cap, 600 nautical miles from where anyone was looking, the USS Seawolf had been waiting for 10 days. The Seawolf, SSN-21, the lead boat of her class, the fastest and acoustically quietest attack submarine ever commissioned into the United States Navy, had not used GPS or satellite communication links during her transit or her wait. She had navigated under the ice using gravimetric reference systems that compare local gravitational field measurements against pre-surveyed charts of the polar seabed topography, combined with an inertial navigation system whose accumulated drift error over 10 days remained operationally negligible. She had used the ice keels, the downward projections of pack ice that extend meters into the water column, as acoustic scattering surfaces, allowing her to maneuver in ways that broke up her own sound signature against the natural noise of ice movement. She had been invisible. She had been patient. She had been positioned within acoustic range of the Kola Peninsula's Northern Fleet infrastructure for the duration of the entire operation. Her mission, when it activated, was not kinetic. The Seawolf deployed 5 Mark 39 Cetus decoy systems and a suite of advanced acoustic projection emitters from external release points. When these systems activated, they began broadcasting a composite signal package, the combined acoustic signatures of multiple Virginia-class attack submarines simultaneously opening their vertical launch system hatches. On the Northern Fleet's passive sonar monitoring screens at Severomorsk, the signature package resolved as what appeared to be an encirclement. Multiple U.S. attack submarines surrounding the Kola Peninsula's primary naval base, all registering the unmistakable acoustic precursor to a missile launch preparation sequence. The duty officer at Severomorsk had a choice between 2 threat assessments, one of which was a catastrophic underreaction and one of which was not. The Northern Fleet began recalling assets. The pressure operation against the British forces in Norway was competing for command attention with what appeared on every monitoring screen to be an imminent threat to Russia's nuclear submarine home port. Assets that had been pushing west pivoted to defensive postures. The Murmansk BN jamming complex, which requires dedicated power allocation and crew attention to maintain at full operational output, began drawing resources being redirected toward the Kola defense picture. At Camp Viking, the interference dome flickered. Unit 30, Commando's reserve communications equipment, hardened against electronic warfare, held back specifically for this contingency, began finding frequency windows that were no longer saturated. Russia's response to the acoustic threat picture was to go to the countermeasures it had available. The PMK, two smart seabed minefield in the approaches to Severomorsk, was activated. Two 160 strategic bombers launched from Engels Air Base and began deploying active sonobuoy patterns across the polar ice cap, building an acoustic search picture of the submarine contact threat their monitoring systems were showing. The USS Seawolf, lying motionless with all propulsion systems secured and drifting on natural current beneath 3 meters of pack ice, was generating no acoustic signature for those sonobuoys to find. A submarine with no moving parts in water that is itself full of acoustic noise from ice movement and current is, from a sonar perspective, not there. But the Tu-160 patrol was closing the search geometry. The probability of a chance acoustic detection from a buoy dropped directly overhead was not zero. The Seawolf's captain made a calculation that involved the words "not zero" and a set of options, none of which were without significant cost. The Seawolf went to maximum ballast blow and full ahead power simultaneously. 9,000 tons of nuclear-powered attack submarine accelerated from rest toward the underside of the polar ice cap at a rate that the hull design makes possible only because the Seawolf-class bow was specifically engineered for ice-breaking operations. The bow structure impacted the pack ice at an angle and speed that shattered 3 meters of frozen Arctic Ocean in a sound event that registered on every sonar system within 50 nautical miles. The Seawolf surfaced inside the Russian reconnaissance formation, 400 meters at the closest point from the Yuri Ivanov intelligence collection ship. The vertical launch system hatches opened. 50 Tomahawk cruise missiles, visible on every radar and optical system in the formation, pointing at a targeting solution that the Russian formation commanders did not need a fire control computer to evaluate. The Seawolf's captain transmitted on open international frequency. The message described freedom of navigation rights, documented the illegal seabed infrastructure operations, and specified the precise consequences of any hostile action directed at the surface submarine or at NATO forces in Norway. 15 minutes. The Russian formation did not move for 15 minutes. Every weapon system in that formation was pointed at a target that carried enough Tomahawks to end the operational utility of every vessel present before any of them could complete a targeting sequence. The math of a close-range engagement between a nuclear attack submarine's weapons complement and a collection of intelligence ships and an icebreaker did not require extended analysis. The withdrawal order from Moscow arrived at the 14-minute mark. The Yuri Ivanov turned northeast. The Ivan Papanin-class platforms reduced power on the Murmansk BN systems and began repositioning toward Kola. The Lasharik and her support vehicles ceased operations on the seabed cable and withdrew to depth. On the screens at Camp Viking, the GPS data stabilized. The interference dropped out of the communication frequencies. The Watchkeeper drone operators re-established uplink. The tactical picture rebuilt itself from nothing in under 4 minutes. The RFA Proteus's sensor systems came back online and documented the cable severance coordinates with enough precision for the repair vessel that was already repositioning to begin recovery operations. The confrontation was over. Britain's forces were reconnected. The fiber optic infrastructure was recoverable. NATO's Arctic Sentry operation would proceed, delayed but intact. The cost accounting was asymmetric in ways that ran in both directions simultaneously. Russia had achieved what they came to do operationally. They had demonstrated that NATO's Arctic surveillance expansion could be preemptively degraded, that Britain's forward presence could be electronically isolated, and that the legal architecture of international maritime law contains exploitable gaps large enough to thread a nuclear-powered deep submersible through. None of that operational demonstration was undone by the Seawolf's surface maneuver. The data on how Britain's forces responded to communications loss, how the Norwegian escorts behaved when constrained by maritime law obligations, how long it took NATO's legal review process to authorize a response, all of that was collected and transmitted before the withdrawal order arrived. The United States had spent its most valuable Arctic asset. The Seawolf's ability to operate undetected beneath the polar ice cap for extended periods had been one of the most closely held capabilities in the U.S. submarine force. Every acoustic signature she produced during the ice-breaking surfacing maneuver was recorded by Russian systems. every operational detail that could be inferred from a nuclear submarine operating under the polar ice for 10 days without satellite navigation or communication was now part of Russia's technical intelligence file on American undersea capabilities. The exchange was, from a pure capability disclosure standpoint, not entirely favorable for Washington. The Seawolf saved the operation. She also revealed herself to do it. The Arctic is not a domain where either side holds unchallenged advantage. What the engagement demonstrated was that both sides have developed significant capabilities that the other side had not fully characterized. Russia, with her seabed intervention systems and strategic electronic warfare architecture, the United States with a submarine capability to operate under polar ice at operational depths without external navigation reference for periods that Russian doctrine had not modeled as achievable. The next round of this contest will be shaped by what each side learned in this one. Russia will model more carefully for the possibility of extended duration, undetected U.S. submarine presence under the ice cap. NATO will adjust its legal authorization frameworks to close the gaps the Lawful operation exploited. Both sides will invest in what they discovered they were lacking. The ice is permanent. The contest beneath it is not finished. Whether NATO's expanded Arctic monitoring presence changes the strategic balance in the north, or whether this engagement was precisely what Moscow needed to understand where the real lines are drawn, that question does not have a clean answer yet. The powder has been measured. The fuse has been observed. The next time someone in this theater makes a decision under pressure with incomplete information, the outcome of this engagement will be part of the calculation on both sides. If this breakdown gave you a clear picture of how gray zone operations in the Arctic actually function, subscribe and share it. More of these analyses keep coming as long as you are here for them.